will make one entry in their routing table. Once I will configure IP address on any interface of router, first of all router will make one entry in their routing table. What will be the entry? First router will calculate the network ID of this IP address. See, syntax to assign IP address on interface is very simple. Like you need to run command in interface mode. You will run this command. Interface f0/0 fast ethernet 0/0 and then IP address 192.168.1.100. First, once I will hit enter, router will calculate network ID of this IP address, because at the same time you will provide subnet mask also. So subnet mask is 255.255.255.0, right? I will run this command on router number 1. Router 1 will calculate network ID of this IP address. Network ID of this IP address. What will be the network ID of this IP address?
192.168.1.0.
1.0/24. So it will make one entry in their routing table that 192.168.1.0 network is directly connected on my fast Ethernet 0/0 interface. Right. In the same way, here one more command I need to run. As you know, by default router interface is shut down, so you need to run no shut command, no shut, and then we will configure one IP on fast Ethernet 0/1 also. Here we will run IP address 192.168.2. 192.168.2.100 and 255.255.255.0, and then here also we will run no shut command and exit. Right, so on this router we have configured IP address on both interface. Router 1 is going to determine the network ID of both IP address. So one network ID is 192.168.1.0/24 and second one is 192.168.2.0/24. Right, this network 192.168.1.0/24 is connected on fast Ethernet 0/0, and this network 192.168.2.0 is connected on fast Ethernet 0/1/0. 1/0. Fine. Now inside the routing table you will see there will be two entry. Okay, and let's suppose that this router is receiving a traffic from one another router. Let's say one router is receiving one traffic. In the traffic, in the packet, destination IP address is, router is not going to check source IP address, right? Whenever router will receive the packet, like switch, whenever switch will receive the frame, first switch will check source and it will update the MAC address table. But when router will receive the packet at layer 2, it will definitely check layer 2 information. If layer 2 destination MAC is the MAC address of router interface, then only it will accept the traffic at layer 2. After that it will check layer 3 information. At layer 3 information it is going to check destination IP address. So let's say destination IP is 192.168.1.1. destination IP is 192.168.1.1. It is router 1 is receiving a packet where destination IP is this one. So behavior of router is just router is going to check, compare destination IP address in the routing table, and it will find the exit interface. It will compare this destination IP address with the routing table, and after that router is going to check exit interface. So can anyone tell me what will be the exit interface for this destination?
We have 0/0.
0/0, and here let's say destination is 2.1. Now exit interface will be fast Ethernet 1/0. Right. So guys, if destination is 1.1, what router will do? Router 1 will remove layer 2 header. Actually in the packet, in the actual traffic, there will be layer 3 information, maybe layer 4 information, layer 7 information are there, and layer 2 information are there, layer 3 information are there. At each layer there will be one header. Information means nothing but header, right? Like if it is an DNS traffic, so there will be DNS header at layer 7, there will be TCP header, UDP header at layer 4, there will be IP header, there will be at layer 3, there will be data link layer header at layer 2. So at each layer there will be some information. So if I will talk about the actual information, so inside the packet there will be application layer information. We are not going to talk about application layer information because router is going to forward traffic on the basis of layer 3 information. Router will never check layer 4 information. It will check information till layer 3 only. Let's say router is receiving a traffic of application layer. So router is not going to check what is the information inside the traffic at application layer. It will ignore. At transport layer also it is not going to check what information are there inside the transport layer. It will check which header? Layer 2 header and layer 3 header. So at layer 2, let's say source is someone is sending this packet whose IP address is 10.1.1.1. Source IP is 10.1.1 and destination IP is 192.168.1.1. After that, at layer 2, information source MAC is, let's say, 0A and destination MAC is 0B. Fine. So destination MAC should be the MAC address of router receiving interface. Let's say router is receiving this traffic on fast Ethernet 2/0. So MAC address of 2/0 should be 0B. Then only router will accept it. And if destination MAC is matching with the interface MAC address, it will remove layer 2 information. It will check type field, right, to came to know that at layer 3 to which protocol I need to forward the actual information. So there will be information about IPv4 protocol. It will remove layer 2 header and it will check layer 3 header. Inside the layer 3 header, it will check destination IP. Destination IP is 192.168.1.1. It will compare in routing table. In routing table here, match will here destination is this one. Destination IP is 192.168.1.1 and this IP address belongs to this network 192.168.1.0. So inside the routing table, yes, for this network, this IP address there is one entry, and for this network exit interface is fast Ethernet 0/0. So router will forward this actual traffic from fast Ethernet 0/0. It will not change any information at layer 3, but it have removed layer 2 information. So again it have to add layer 2 information. So at layer 2, again it is going to add source MAC. So source MAC will be the MAC address of exit interface. Whatever MAC address, let's say MAC address of this interface is, 1 minute guys. What this router will do, let's say MAC address of this interface is 0C and MAC address of this PC is 0D. MAC address of this PC is 0D. So what router will do? Router will check that destination belongs to my network. If destination belongs to my network, then destination MAC will be the MAC address of destination. If destination belongs to different network, then MAC address will be the MAC address of gateway. So in this scenario, destination means 1.1 PC, 1 belongs to same network. So source MAC will be here 0C and destination MAC will be here 0D, and after that it will exit this data from fast Ethernet 0/0 interface. Okay, this is how router is going to take forwarding decision. Is it clear? Is it clear guys?
Clear.
Clear. And now let's say here IP address is different, not this one. Here subnet mask is 2/25. Here network ID is 192.168.128/25. This time both network belongs to these two network are different or same?
Different.
Again different, both are network ID. So this time router will have again two entry in their routing table. One is 1.0/25 and one is 128 1.128/25 is connected on fast Ethernet 1/0. And this time let's say router is receiving one traffic from again sources. Yeah,
192.168.
128.0 or 1.128?
128.0.
128.0 here, 128.0, 128.0, this one. Yeah, okay. And now let's say router 1 is receiving a traffic again from source 10.1.1.1, and this time destination is 192.160.1.1. What will be the exit interface for R1? Exit interface, see,
Zero.
Zero.
this time destination IP address is matching in both network, yes or no? Destination is matching in both network, in this also and this also. No. If destination is 1.1, it will forward traffic from fast Ethernet. Here is this one is incorrect now. 1.128. It will be 1.128. 1.128 now. One dot 128. This is network ID 1.128. This is the network ID, right? After subnetting, this will be the network ID. Okay. So see, destination IP address is matching in both network, but router use longest prefix match method to forward traffic. Means destination IP address is matching longest prefix, means longest prefix length is matching in which subnet. So you tell me here, longest prefix length is matching in which subnet? Here in the routing table again we have two subnet, but in the upper one, yes, where destination belongs to 192.168.1.12, 192.168.1.126. It will use which interface? Fast Ethernet 0/0 interface. And if destination IP address is from this range 1.129 to 192.168.1.254, it will use exit interface as fast Ethernet 1/0, right? Correct.
1.128 to 254.
1.128 is network ID.
Okay.
Correct. Okay, so first of all, see routing table of router. What I am going to do here on this router, I am going to configure IP address. Let me access R1, this router. Is font size visible?
Yes.
Great. Okay, by default, if you will check routing table, so IP route, this is command to check routing table. You can see there is no any entry. There is no any entry. And once I will assign IP address interface fast Ethernet 0/0, say no shutdown, and then IP address 192.168.1.1.255.255.255.0. Right, it will calculate network ID of this IP address. How it will calculate network ID? You know the actual process is converting both subnet mask and IP address in the binary, perform AND operation on that, and then you will calculate network ID. See, after running this IP address, if I will check routing table, do
Sir,
so.
slash 25 na, so subnet will be 255.128.
Okay, 128. Fine. Do so IP root. Now if I will check routing table, you can see there is one entry. This is local IP address. One is local IP address, means IP address on this interface with /32 192.168.1.1/32 is directly connected on fast Ethernet 0/0. Router is not going to use this entry. This is important. This one is important. Connected network. C stands for connected. Here you can see connected. C means connected. This is a connected network. Manually, we can also tell network ID and exit interface to router, right? That is a static method. And with the help of routing protocol, also routers are going to learn networks in their routing table. But this network is connected network, directly connected on fast Ethernet 0/0. So what it's saying, connected network 192.168.1.0/25 is directly connected on fast Ethernet 0/0. So whenever this router will receive a packet where destination belongs to this network, router will exit that packet from fast Ethernet 0/0. Okay, in the same way, here I am going to configure one IP address on this interface 1/0 also. Say interface f1/0 no such, and IP address 192.168.1.129, or what we can say, let's say 200 255.255.255.0 128, right? And here let me correct it. This is 202.200 here. Done, guys. Now again, if we will check routing table, do so IP route, you can see in the routing table there are two entry now. One is this one, means this network is connected on fast Ethernet 0/0, and this network 192.168.1.128 is connected on fast Ethernet 1/0, and this is 0/0. 192.168.1.0 is connected on fast Ethernet 0/0, and 192.168.1.128 is connected on fast Ethernet 1/0. Fine. And now if we will configure one IP address on this PC, let's say PC1 have one IP address that is 192.168.1.1/24, and what will be the gateway? 192.168.1.100. This will be the gateway.
Prabhul,
Hmm.
actually you assigned fast Ethernet 0/0 IP address at the same 1.1, I think.
1.1 or 1.100?
Yeah, let's just check on the fast Ethernet 0/0.
So IP interface brief. Okay, yes, here I have assigned 1.1. So let me correct it. Let me assign 100 here. Fast Ethernet 0/0 IP address is 192.168.1.100 and 255.255.255.128. Okay, and so IP interface brief. Correct. Now on this PC, I am going to assign this IP address 192.168.1.1/25, and gateway is 192.168.1.100. It's checking duplicacy. After some time it will assign this IP address on their interface. So all. So IP all, I think. Yes, here you can see the IP address is this one, gateway is this one, and MAC address is this one of this machine. Fine. Now here to this PC also I am going to assign one IP 192.168.1.2/25, and gateway is 192.168.1.100. Now tell me, if PC1 want to communicate with PC2, PC1 want to communicate with PC2, if PC1 want to communicate with PC2, will switch forward traffic to router?
No need. It will be communicate within the switch because it is the same network, right?
This is one dot, yes, because both PC belongs to same network. So whenever these device need to communicate inside the network, default gateway is not required, right? It will not forward. Switch can forward traffic inside the network. PC1 will forward the traffic to switch 1 and switch 1 will forward it to switch 2, means PC2. Because switch will have MAC address of PC1 on E0 and MAC address of PC2 on E1. And switch is maintaining MAC address table. According to MAC address table, switch can forward traffic of PC1 to PC2 and PC2 to PC1. Fine. But if PC1 want to communicate with PC3, here IP address is 1.129, let's say. Here IP address is 1.130, let's say. If PC1 want to communicate with PC3, this time destination belongs to different network, right? So let me configure one IP here. IP 192.168.1.129/25 and gateway is 192.168.1.200. Okay, and then one IP address on this PC also, PC4, IP 192.168.1.130/25 and 192.168.1.200 is the gateway. Okay, we have configured the IP address on all PCs, and now I am going to ping. Let me reduce this size. Okay, now hope topology and console both are visible to you. Here see, on router 1 routing table is clear. Hope this entry is now clear for you. Both are directly connected entry, and here in GNS3 we cannot access switch, so I cannot show you the MAC address table of switch. But if from PC1, if you will ping 192.168.1.2, see ping is working, and here when PC1 will encapsulate ICMP traffic, destination MAC will be the MAC address of PC2, will be the destination device. Destination MAC will be the MAC address of PC2 because destination belongs to same subnet. So whenever we are forwarding any traffic to this network, what this PC will do first? This PC will check first. It will convert this IP address into binary. It will convert their own MAC address into binary, and it will check that both IP address belongs to same subnet or different subnet. Both IP address belongs to same subnet or different subnet. See, destination is 192.168.1.2 and my IP address is 192.168.1.1. Means my network ID is 192.168.1.0. Destination network ID is 192.168.1.0. Both are same. Means destination belongs to same network. That means destination MAC address will be the MAC address of destination device. But when I will ping this IP address 192.168.1.129, so this time again PC is going to calculate network ID. This time my network ID of this PC is 192.168.1.0 and destination network ID is 192.168.1.128. This time destination belongs to different subnet. Yes or no? So whenever destination belongs to different subnet, then MAC address will be the MAC address of default gateway. MAC address will be the MAC address of default gateway, and see ping is working or not. So yes, ping is working. And now here if you will check ARP table, how I can check ARP table here? ARP. Inside the ARP table there is one entry. This entry you can see, and this entry. So PC1 know the MAC address of 192.168.1.100 and 192.168.1.2. PC1 don't know what is the MAC address of 1.129. Yes. PC1 will never know what is the MAC address of PC3 because PC3 and PC4 belongs to different subnet. and whenever destination belongs to different subnet, whenever destination belongs to different subnet, then MAC address will be the MAC address of default gateway. Means at layer 2, if I will talk about at layer 2 communication, so at layer 2, end user devices responsibility is to forward traffic to default gateway at layer 2, right? At layer 3 only, destination IP will be the IP address of destination device which belongs to different subnet. Because at layer 2 PC cannot resolve the MAC address of any device who belongs to different subnet, because to find the MAC address PC need what? PC need to generate one ARP request, and ARP is an broadcast, and router cannot forward the broadcast packet. Router cannot forward broadcast message from fast Ethernet, let's say 0/0 to fast Ethernet 1/0. So router will drop the broadcast traffic. Okay, so this is first rule, that whenever we are going to communicate with a device who belongs to same subnet, then destination MAC will be the MAC address of destination device, and whenever destination belongs to different network, that time destination MAC will be the MAC address of default gateway. Now see, try to understand one problem here. Problem is by mistaken here, what I have did, by mistaken on PC1 I have configured wrong subnet mask. On PC1 I have configured this IP 192.168.1.1 and /24 and 192.168.1.100. default gateway is correct. I have configured wrong subnet mask by mistake. Now what will happen? Can anyone tell me, can I ping now this time 192.168.1.129? Because this time see, destination belongs to my network, but in the topology you can see destination belongs to different subnet, because this time PC will calculate network ID of destination with /24. So my network ID is 192.168.1.0, destination network ID is 192.168.1.0, both are same, means destination belongs to same network. So this time what will happen? Anyone know this?
Communication should be happen, right? If the other device is considered in the same network, so it can be communicate, right?
Yeah, but how? See, let me do one thing. On interface fast Ethernet 0/0 of router 1, I am going to run one command, interface fast Ethernet 0/0, and say no IP proxy ARP. Now communication will not happen. See, ping will not work. Just wait, let me do one thing. Clear ARP cache and show IP ARP 192.168.1.200. okay, and 192 MAC address is there. 192.168.1.129. What is happening?
I think earlier you gave F0/00. That is correct?
Where? 0/0. Yes, that was correct.
Okay.
Here I have disabled proxy. Here by default one service, one feature is enabled on router interface. Because of that, this is only this feature proxy ARP is only for the administrator, that if administrator will configure wrong subnet mask on PC, then also PC can communicate with the user who belongs to different subnet. So here I have disabled this feature, but I am trying to clear this entry.
No, F0/0 and F0/00 are the same.
Yeah, F0 0 0 or 00 both are same, na?
Okay.
Both are same. Okay, so here ping is working because this entry is there in the ARP table. I will try to clear ARP cache and interface, let's say fast Ethernet 1/0, and so MAC address table. So ARP, still ARP entry is there. What we can do then, we can shut down the interface for a moment. Interface fast Ethernet 1/0, say shutdown, and then no shutdown, and so ARP. Now ARP is not there. Now let me try to ping. See, ping is working? No. Why ping is not working? See guys, why ping is not working? The reason is, yeah, tell me if anyone want to speak. Here I am pinging this IP address 192.168.1.129, and here IP address is 1.1/24. So this PC will check that destination belongs to my network or different network. So according to this slash value, it will calculate network ID, right? So their network ID of this PC is 1.0, and network ID of destination is also 1.0. Both are same. So PC will think that destination IP address, this IP address belongs to same subnet. So this machine will generate ARP request. ARP request. In ARP request, as you know, source MAC will be the MAC address of this PC, destination MAC will be the 0.0.0.0, and at layer 2 destination MAC will be all F, and target MAC address will be, target IP address will be this IP address. Target IP address at layer 2, source MAC, let's say MAC address of this machine is 0D, and destination MAC is all F. And here target IP address will be 192.168.1.129. This is broadcast message. This PC will forward this message to switch. Switch will forward it to router. What router will do? Simply router will drop it. But if proxy ARP is enabled here, proxy ARP is enabled here. So what is the meaning of proxy? Proxy means someone else instead of someone. Let's say means if proxy ARP is enabled on this interface fast Ethernet 0/0, that means we are telling to router that if you have reachability to this IP address 192.168.1.129, if you can reach to this PC, to this IP address, then please share your own MAC address instead of the MAC address of 192.168.1.129, because router cannot forward this broadcast message to PC number 3, but router can do one thing. Router can share their own MAC address instead of MAC address of this PC. So this is concept of proxy ARP. So here by default proxy ARP is enabled on all Cisco routers interfaces. This is the interview question. Interviewer can ask you this question, that here IP address is 192.168.1.129. Here IP address is with /25. Here IP address is with /24. By mistaken we have configured wrong subnet mask. Then will it work? Ping will work. If ping will work, then how ping will work? So answer is by default proxy ARP is enabled on this PC. So see, if proxy ARP is not enabled, then ping is not working. So actual concept is, if we have configured the wrong subnet mask on PC, then communication will not happen. PC1 cannot ping to PC3. You can see here PC1 is not able to ping PC3. And here on fast Ethernet 0/0, if I will enable proxy ARP feature, interface fast Ethernet 0/0 IP proxy ARP, if I will enable this feature, there are multiple types of ARP. Till now we understand gracious ARP, we understand normal ARP to find the MAC address of destination device. Then we have proxy ARP. Today we understand proxy ARP, and in upcoming day you will understand more ARP, more types of ARP.
Sir,
So on, yeah.
can we ping PC1 from router if proxy ARP is disabled at F0
Yeah,
slash
yeah.
0.
Why not? If the PC1 will generate ARP request for this IP address, definitely PC will generate ARP reply. Proxy ARP is disabled here.
Okay, so I'm also having one doubt. See, if I'm
Yeah.
going to disable proxy or
Mhm.
whether it is really any impact, because whenever we are receiving the audit points, so in that audit points, they are suggesting us to disable the proxy or.
Yeah.
So what makes sense? So what is the usages here?
If you will disable the proxy ARP, then router will not share their own MAC address instead of any other device MAC address.
Exactly, I tried when I received that audit point. So if I'm going to disable that proxy, so at that time we were facing like reachability issue, like I'm not able to reach that applications or servers like that.
If you are disabling proxy ARP, you are getting reachability issue.
Yeah, exactly.
No, proxy ARP, you know, that means you have configured different subnet mask on your LAN devices, your end devices, or we will check that later. Okay, first understand the concept of proxy ARP. What is proxy ARP? Then we will discuss your scenario. What is the scenario? For that, I have to understand your network, how it's look like. Okay,
Okay.
we'll discuss. Don't
Okay.
worry.
Okay.
First of all, see on this PC, I am going to check ARP table. Inside the ARP table, there is only one entry. This is the MAC address of which device? Default gateway, right? And this PC is going to ping this IP address 192.168.1.129, and this PC cannot resolve the MAC address of this IP address. But according to this PC, this destination belongs to same subnet. So in this type of scenario, proxy ARP should be enabled on fast Ethernet 0/0 of router 1, right? So on this router, I am going to enable proxy ARP. After enabling proxy ARP, again I am going to ping this IP address, and this time ping is working. And you can see the ARP table. Inside the ARP table, ARP. Inside the ARP table, you can see MAC address of both IP addresses same. 192.168.1.100 as well as 192.168.1.190 means 129. MAC address of both IP addresses same, because when our router will receive ARP request for this IP address, it will share their own MAC address. Whenever router will receive ARP request for this IP address, it will not drop the ARP request, because proxy ARP is enabled. It will share their own MAC address instead of the MAC address of 192.168.1.129. So router 1 is actually telling to PC1 that whenever you need to forward traffic to this IP address, you can forward to me to this MAC address, and I will forward it to this IP address. Means router 1 is telling to PC1 that MAC address of this IP address is this one, my MAC address. It is sending their own MAC address instead of the MAC address of 192.168.1.129. So that's why we are saying it proxy. Proxy means it is sending someone else MAC address. It is sending, router is sending their own MAC address instead of someone else MAC address, right? And command to check that proxy ARP is enabled or disabled is show interface fast Ethernet 0/0. We can run this command, show interface fast Ethernet 0/0. On any interface you want to check proxy ARP is enabled or disabled, you can run this command, show interface, then interface type, then interface ID, or show IP interface, I think. So IP interface fast Ethernet 0/0, and here somewhere you can see proxy ARP is enabled, right? On fast Ethernet 0/1 also, 1/0 also, we can see by default proxy ARP is enabled, right? So proxy, there is some concept of proxy ARP in static routing. If you are running a static routing in your network, there is concept of proxy ARP, right? That's why I just try to make you understand what is the meaning of proxy ARP. Proxy ARP is generally, you know, we come up with proxy ARP concept for the administrator, that whenever we will configure wrong subnet mask on the PC, still PC can access the network resources. Because let's say here I have one network like this. Here I have one server in the network. This is server, and server IP address is 10.1.1. 1/24, and here we have one router, and this server is connected with router, let's say, and here we have one switch, and this switch is connected with lots of PC. Let's say PC1, PC2, PC3, and PC4. Here IP address is, let's say, 10.1/8, and here IP address is 10.2/24, here IP address is 10.3/24, here IP address is 10.4/24. On all computer IP address is correct, but on PC1 IP subnet mask is incorrect, right? So according to PC1, this server belongs to same network or different network. According to PC1 only, the server belongs to same network. According to PC2, 3, 4, server belongs to different network. Because when PC2 will find the network ID of destination 10.1.1. Sorry, here IP address is, let's say, 10.2.1.1.1, 10.2.1.1. 10.2.1.1. So when PC2 will calculate the network ID of destination, it will calculate 10.2.1.0. This is the network ID of destination. According to PC3 also, this is the network ID of destination. According to PC4 also, this is the network ID of destination. But according to PC1, network ID of destination is 10.0.0.0. Means according to PC1, destination means server belongs to same network. So PC1 will generate R for destination device, and PC2, 3, 4 will generate R for default gateway. PC1 should also generate R for default gateway. But no problem here, if we have configured the wrong subnet mask, we have proxy R feature on this interface, and by default this feature is enabled. So whenever this PC1 will generate R for this IP address, router will share their own MAC address instead of the MAC address of this device. And this is how PC1 can access this server. Getting my point?
Sir, is there any security issue because of this?
No. No security issue is there. This is for LAN purpose, brother, and we are using this method in static routing as well. So this is the concern why we come up with proxy R feature. Okay, so in routing, first of all, by default proxy RP is enabled. Whenever we will configure IP address on interface, router will make one entry in their routing table, right? Like this. And whenever router will receive any packet, it will compare destination IP address with routing table. After that, it will find the exit interface, right? It will find the exit interface. And it will check, see, in the routing table there is multiple entry, like here we have 2 entry. So it will check that this destination IP address belongs to which subnet. So it will check bits, total number of bits. So in the in first 8 bits is matching in both entry, yes or no? First 8 bits is matching in both entry. There are 2 entry in the routing table, 192.168.1.0 and 192.168.1.128. First 8 bit is matching in both entry, then it will check second 8 bits. So again 168. In second octet, value is 168. Again matching is both entry, then it will check third octet. In third octet, value is 1. Value is 1. Again you can see it is matching in both entry. Then it is going to check what? Last octet value. And last octet value is 1. Means if you will convert 1 into binary, what will be the binary of 1, guys? 1, 2, 3, 4, 5, 6, 7, 8. This is the binary of 1. Am I right? This is binary of 1. And if you will, here you can see network ID is this one. If network ID is this one, 192.168.1.0, what will be the binary of 4th octet, last octet? Because in last octet, now we are going to check how many bits is matching, maximum bits is matching in which network. Maximum bits is matching in which network? we have 2 entry in the routing table. I will check that destination IP address belongs to which network. So here binary of 4th octet will be 0 0 0 1 2 3 4, all 0, right? And if I will talk about the binary of this network ID, this network, so binary will be 1 2 3 4 5 6 7, right? Like this. This is binary of 4th octet. Now you tell me destination belongs to which network?
0.
0/0.
Zero.
It will use which interface as a exit interface, 0/0 or 1/0?
Yes, 0/0.
Because in this entry you can see how many bits is matching. 8 plus 8 plus 8, 24, and plus 7 bits here. 7 bits here, yes or no? In 4th octet. But in this entry, how many bits is matching? Only 24, because here value is 1, here in the packet value is 0. So in this entry, in the lower entry, only 24 bits is matching. In the upper entry, how many bits is matching? How many bits is matching?
31.
31 bits is matching, right? So it will use this as an exit interface, fast Ethernet 0/0. This is nothing but longest prefix match, okay? And router will use same method to learn prefixes from routers as well. Let's say this router is connected with one another router, and this router R2 is advertising some prefixes to router number 1. Maybe router 2 is advertising 100 prefixes to router number 1, right? And same network, some other router is also advertising to this router. So again router will check that which router is advertising the best network. For that it will check longest prefix match first, that from which network I am getting longest prefix match. We'll understand it later, don't worry. For now, hope it is clear that how router is going to take forwarding decision. If router have multiple entry inside the routing table and it will receive the packet, how router is going to take forwarding decision, how it will choose which will be the exit interface. Is it clear? And what is proxy ARP? Is it clear?
Clear,
To all? Okay. Now here everything is fine. We are able to PC1, PC2, PC3, 4 all are able to communicate with each other, right? We don't have any problem here, because see, both network means this network and this network is connected with router number 1. So router 1 know both network, because of that only these two network are able to communicate with each other. Now let's say here I am going to, let's say, delete this part. Let me delete it. Here this is the topology now. Let's say this is the topology now. Here subnet is not 25, let's say 24 is there. Here this is the IP address. Switch PC1, PC2. Here IP address is 1.1. Here IP address is 1.2. Okay, and my LAN 2 is connected with another router this time. Let's say here is R2, and R2 is connected with one switch. Switch 2, and here we have again 2 PC, PC2, PC3, like this. Now the first question is, how many broadcast domain are there?
3.
3 broadcast domain are there, right? This time, yes, definitely, very good. So we need 3 subnets. Let's say here my subnet is 192.168.2 2.0/24. And between routers, you know, in always in the entire course, see, between router 1 and router 2 I will use 2L network. 2L1 2 router 1 router 2, then 2L.1.1.0/24. This network between R1 and R2. Okay, on router number 1 IP address will be 12.1. Here IP address will be 12.1, and on router number 2 IP address will be router number 2. I will use this scheme to assign IP address between routers, right? It's totally depends on you. You can use any IP address between router. This doesn't matter. You can use 10.1.1.0. you can use any other network, any network between routers, right? Between routers doesn't matter what network we are using. Okay, now first of all I am going to configure this topology. Like here I have console, and let me increase the size. Let me try to increase the console size. I think console size should be larger. Not working. Okay, leave. I will check it. Forget. Router 2, PC3, PC4. Now very quickly let me configure IP on router number 1 first, because I need to correct the IP address. So interface fast Ethernet 0/0. Here no set is already done. IP address 192.168.1.1.100 and 255.255.255.0. Exit interface fast Ethernet 1/0. Here I am going to say IP address 12.1.1.1 255.255.255.0 and say no set. After that, okay, router 1 configuration is done. Router 2. On router 2, where is R2? Here it is. On router number 2, I'm going to say interface fast Ethernet 0/0, no set, and IP address is 192.168.2.100 255.255.255.0. Exit interface fast Ethernet 1/0 no set, and IP address is 12.1.1.2 255.255.255.255.0. Done. No set. Now on router number 2, if I will check routing table, so IP route, how many network will be there? How many network will be there inside the routing table of RJ network? So here on router number 2, one network is 12.1.1.0 and one network is 192.168.2.0. Now let me configure the IP on PC1. PC1 IP address is 192.168.1.1/24 and 192.168.1.100. Very good. On PC2, IP address is 192.168. Let me show you the topology also. So hope now topology is also visible. 192.168.1.2 and /24 and 192.168.1.100 is the gateway. Done. Then PC3, here IP 192.168.2.1/24 and 192.168.2.100 is the gateway, and finally PC4 IP 192.168.2.2/24 and 192.168.2.100. Now can PC1 ping to PC2? First question. Can PC1 ping to PC2?
Yes.
Yes. 192.168.1.2. Yes. Can PC1 ping to PC3?
No.
Why?
It needs routing.
Where? Okay, if I will ping PC3 from here, PC1, what will happen? On which device my traffic will drop?
R1.
Let's say I'm ping R1. Why R1 will drop the packet?
Because this L3 is an
R1 doesn't know that network.
Yeah.
192.168.2.0.
Yeah, exactly. See, when I am pinging this IP address 192.168.2.1, 2.100 or 2.1, what will happen? This PC will encapsulate a packet where source is 192.168.1.1 and destination is 192.168.2.1. Source MAC will be the MAC address of PC1, destination MAC will be the MAC address of gateway, because destination belongs to different subnet. When PC will encapsulate the packet, it will forward to switch will forward it to router 1. As you know, router always check routing table to forward the traffic. When router will receive this traffic, it will check their routing table. So IP route, and it will compare destination in routing table. It will compare destination IP in routing table. So is there any route available for this network inside the routing table? No. There is no route available inside the routing table. That means router 1 don't know where is 192.168.2.0 network or 2.1, right? In the same way, when router 3 IP address is this one, 192.168.2.1 and 2.2, and gateway IP address is 2.100. When PC3 will encapsulate any packet for, let's say, PC1, again this time source will be 192.168.2.1 and destination will be 1.1. It will forward the packet to switch will forward the packet to router 2. Router 2 will check their routing table. It will compare destination IP address in routing table, router 2 routing table, and inside the routing table of router 2 there is no any route available for this network 192.168.1.0, because by default router know only directly connected network, means router 1 know only 192.168.1.0 and 2L network, because these two are directly connected. Router 2 know only this network and this 2L network, directly connected network. Means here we have to tell to router 1 that this network 192.168.2.0 network is connected with router 2, or actually, as I told you, that router need two things to build routing table. Inside the routing table, you can see there are only two information. One is network ID, and another information is exit interface. So we can tell to router 1 that whenever you need to forward the traffic to 192.168.2.0, you will forward traffic from this interface. Exit interface for this network will be fast Ethernet 1/0. And we can tell to router 2 that whenever you need to forward traffic in this network, exit interface will be this one, fast Ethernet 1/0, right? Actually, we are manually telling to router that whenever, please install this network in your routing table on this exit interface, and this network to R2 with this exit interface. So again, now we have two methods to tell to router about indirectly connected network, because 192.168.1.0 is indirectly connected for router number 2 and 192.168.2.0 is indirectly connected for router number 1. So to exchange indirectly connected network, we have two methods. One is static and another one is dynamic. Guys, in static, manually we will configure the route. In dynamic, we will configure routing protocol. According to that routing protocol, router will automatically exchange the prefixes. If we will configure routing protocol on router number 1 and on router number 2, these two routers are going to communicate with each other, and then they will share their directly connected network with each other. So router 1 will learn this indirectly connected network and router 2 will learn this indirectly connected network. But first understand the static method, how to perform routing manually. Okay, so on router number 1, see, to make one static entry on router number 1, syntax is very simple. IP route, and then the network, which network you want to inject in routing table. So on router number 1, which network I want to inject? Indirectly connected network. Which one is indirectly connected? 192.2.0, this
Slash
network. After that, subnet mask 255.255.255.0, and then exit interface. Exit interface is fast Ethernet 1/0, because this network is reachable from fast Ethernet 1/0 only, right? So let me hit enter here. After running this command, again if I will check routing table, do show IP route, you can see the routing table now. There is one static entry. This S stand for static. This is a static entry. There is one static entry. 192.168.2.0/24 is directly connected on fast Ethernet 1/0. Is it correct entry, guys? First of all, tell me this. Is it right? Is this network directly connected on fast Ethernet 1/0?
No.
No. So if router have installed this network like directly connected, so whenever router 1 need to generate ARP for, let's say, 192.168.2.1, it will direct generate ARP for destination IP address, yes or no? Because destination belongs to my network. This network is directly connected with me, and router 2 will drop the ARP request. For this type of communication, for this type of entry, we have to enable proxy ARP on fast Ethernet 1/0 of router number 2. Right? Let's say here I have configured this entry, and I'm going to disable proxy ARP on 0/ here I am going to say no IP proxy ARP. And on router number 2 also I am going to make one static entry here inside the routing table of router 2, IP route and 192.168.1.0, and subnet mask is 255.255.255.0, and exit interface is fast Ethernet 1/0. Right? Do so IP route. On both router we have configured one static route. Right? Now router 1 no one indirectly connected network, and router 2 also no one indirectly connected network. Now these two networks should communicate with each other, yes or no? Now these two devices should communicate with each other, but let me show you. When I will ping from PC1 to PC2, let me first ping to PC2 1.2. Yeah, ping is working. Let me ping to my default gateway. Ping 192.168.1.100. I'm able to ping my default gateway also. Now I am going to ping PC3. Belongs to different network. PC3 belongs to different network. 192.168.2.1. See, ping is not working. Now this time, who will explain why ping is not working?
We need to advertise same route in R2 also, right?
Sorry?
We need to advertise the network in R2 also.
R2.
Yes.
Yeah, on R2 we have advertised the route.
Oh, already.
IP.
Okay. I didn't notice it that time.
Here is the entry. See what is happening on router number 1. Again, let me follow the packet. When I am pinging this IP address 192.168.2.1 from PC1, it will encapsulate one ICMP packet. Source will be this one, destination will be this one. It will forward to switch will forward to router. Now router will check what? Their routing table. Router 1 will check their routing table. So IP route. In their routing table, it will compare destination IP address with routing table, and there is one route available. Yes or no? One network is there inside the routing table for this destination. Yes or no? So router 1 should forward the traffic from fast Ethernet 1/0. But why it is not forwarding? Because problem is what?
What is the subnet of PC1 and PC?
Huh? PC1.
Uh,
PC1 subnet is /24.
okay.
That is correct. PC1 subnet is correct, brother.
Okay.
Here you can see /24. Correct. Gateway is correct. MAC address is this one. Everything is correct. What is happening? Problem is router 1 have installed this network with like entry is like directly connected on fast Ethernet 1/0. So it will actually, whenever router 1 need to forward packet to 192.168.2.1, it have to add layer 2 header here, right? Layer 2 header. Router always remove layer 2 header and it will rewrite the layer 2 header. On the receiving interface, it will receive the traffic on fast Ethernet 0/0. It will remove the layer 2 header, and while forwarding traffic from fast Ethernet 1/0, it will add the layer 2 header. So when router 1 will forward this traffic from fast Ethernet 1/0, it need to add layer 2 header. In layer 2 header, it will add source MAC and destination MAC. Source MAC will be the MAC address of exit interface. So interface fast Ethernet 1/0 and include, this is the MAC address, source MAC address. This will be the source MAC address and destination MAC address. Important thing is destination. What will be the destination MAC address?
FFFF.
Not FFFF.
No, that will
This
also
is
be the
actual
same.
traffic of PC1.
Actually, we have to point to the next hop only, right? Routing.
It will check
Ah,
ARP table.
it's,
So IP ARP. Inside the ARP table, there is no any entry available for destination IP address. So it will do what? It will generate ARP. It will put this actual information on
12.0 network MAC address, right?
12.0.
The gateway
No,
MAC address.
12.0. Where is 12.0 in the routing table? So IP route. Where is 12.0?
Sorry,
12.0
12.2.
MAC
2,
address
2,
is
2, I
there.
mean 2.
So ARP. So IP ARP. This machine have MAC address of 12.1.1.1 and let me ping 12.1.1.2. Okay, and now if you will check ARP table, you can see 12.2 MAC address is there inside the routing table. But still PC1 is not able to ping PC3. PC1 is not able to ping PC3. You can see ping is not working. And getting reply from router. Router is for dropping the traffic. The reason is what? Reason is router is trying to find the MAC address of 192.168.2.1, but router 1 should find MAC address of 12.1.1.2, 12.2. So always keep in mind, whenever we are configuring a static routing by using exit interface, proxy ARP should be enabled on neighbor device. Here, if I will capture this link, this is capturing between router 1 and router 2. See, now again I am going to ping from PC1 to PC3. Again I am going to ping PC1 to PC3. This one. See, ping is not working. Ping is not working. And are you able to see the ARP request message? Who is generating ARP? 12.1.1.1. For which IP address? 192.168.2.1. Brother, router 1 can never resolve the MAC address of this IP address because this IP address belongs to different subnet. Getting my point? Router 1 is trying to resolve MAC address of 192.168.2.1, which is not possible. Router 1 can never resolve the MAC address of this IP address because this IP address belongs to different subnet. Router 1 can resolve the MAC address of 12.1.1.2. But if we will enable proxy ARP feature on this interface, what router 2 will do? Whenever router 2 will receive ARP request for this IP address 192.168.2.1, 2.1. Router 2 will share their own MAC address instead of the MAC address of 192.168.2.1. See, on router number 1, for till now we don't have any entry in the ARP table for 192.168.2.1. correct? 192.168.2.1, you can see entry is incomplete, right? Router is not able to find the MAC address. Now I am going to enable proxy ARP feature on router number 2. On router number 2, fast Ethernet 1/0, I am going to say IP proxy ARP. Very good. Now again I am going to ping from PC1 to PC3. See, ping is not working, but on router number 1, this time if you will check ARP table, so IP ARP, you can see 192.168. Just wait for some time. It will learn the MAC address of 12.2 as a MAC address of this IP address. 12.1.1.2, you can see now 192.168.2.1. MAC address of 192.168.2.1 is this one, and MAC address of 12.1.1.2 is this one. Same. Both MAC address is same, right? So this is concept of proxy ARP. If proxy ARP, this is, you know, very essential while troubleshooting. Sometimes if you have less number of router, you have configured the static routing, everything is working fine, configuration is correct, but proxy ARP is disabled. Because of that, communication is not happening. So make sure, if we are configuring a static route with exit interface, we have multiple flavor to configure a static routing. We can configure a static routing by using exit interface. We can configure a static routing by using next hop IP address. We can configure a static routing by using both exit interface and next hop IP address. We have 3 methods to configure static routing. So if we are configuring a static routing by using exit interface, proxy ARP should be enabled on neighbor device. Done. This is the first concept. Here now we don't have any problem, but still PC1 is not able to ping PC3. What is the problem now? Now same problem is there on router number 2. Router 2 is trying to resolve. See, when this time, okay, this time see, when PC1 will generate ICMP packet, PC1 will forward this packet to switch will forward it to router number 1. Router 1 will check what? Routing table. So IP route. Inside the routing table, yes, there is one route available for on router number 1, sorry. So IP route, there is one route available for this network 192.168.2.0. It will forward the traffic from fast Ethernet 1/0. Right, and this network is directly connected, so it is going to check ARP table to find the MAC address of 22.1. so it will check ARP table. So IP ARP, inside the ARP table, yes, there is one entry. This is the destination MAC. It will add layer 2 header. It will here add layer 2 header, source MAC and destination MAC. Source MAC will be the MAC address of exit interface. Destination MAC will be the MAC address of MAC address available in ARP table. After that, router 1 will forward this traffic from fast Ethernet 1/0. When router 2 will receive it, router 2 will again compare the routing destination IP address in routing table. First it will check layer 2 information. Layer 2 MAC address will match. This is the MAC address of this interface, fast Ethernet 1/0, receiving interface MAC address. It will remove layer 2 header, and then it will check layer 3 information. At layer 3, it will compare destination IP address with routing table. Inside the routing table of router 2, you can see one network is there. So IP route directly connected 192.168.2.0 is directly connected on fast Ethernet 0/0. So router 2 is going to forward this ICMP traffic from fast Ethernet 0/0. So it will put source MAC and destination MAC. Source MAC will be the MAC address of exit interface, means fast Ethernet 0/0 MAC address, and destination MAC address will be what? MAC address of 192.168.2.1, because this network is directly connected. PC1 will check their ARP table. So IP ARP, inside the ARP table, yes, there is one entry for 2.1. 2.1 MAC address is this one. So this will be the destination MAC address, and it will forward the packet to switch, and switch will forward it to PC3. When PC3 will generate reply, in the reply source IP will be what, guys? Source IP will be 2.1,
2.1.
yes or no? And destination IP will be 1.1, right? There will be layer 2 information also. Source MAC will be the MAC address of PC3, destination MAC will be the MAC address of default gateway. After that, PC3 will forward it to switch will forward it to router 2. Router 2 is going to check what? Routing table. It will compare routing table with destination IP address. So IP route. Inside the routing table, yes, there is one route available for this destination network 192.168.1.0, but this network is directly connected, right, on fast Ethernet 1/0. Again, router 2 will try to resolve the MAC address of destination IP address directly, and you can see so IP ARP. Router 2 is not able to resolve the MAC address of 192.168.1 means destination IP address. 192.168.1.1 MAC address is incomplete because proxy ARP is disabled on fast Ethernet 1/0. So on router number 1 also proxy ARP should be enabled. Interface fast Ethernet 1/0. We can say IP proxy ARP. IP proxy ARP, and now this time if you will check PC1 is able to ping or not. So now you can see PC1 can ping. Just wait for some time. It will okay. Now let me check the ARP table of router 2. So IP ARP, yes, this entry is still incomplete. Just wait for some time. It's because of GNS3, it's taking some time. Yes, now you can see ping is working, right? So this is first method to configure static routing, guys. Now again I am going to disable the proxy ARP. I am going to disable proxy ARP on interface fast Ethernet 1/0. Say no IP proxy ARP, because this time see proxy ARP feature is not required because we are going to configure a static routing so that router will not install indirectly connected network as directly connected. Indirectly connected network as directly connected. Here inside the routing table there was one wrong entry. Like router 1 was installing this network like this network is directly connected on fast Ethernet 0/1. That is not true. So this time on router number 1 and on router number 2, here I have disabled the proxy ARP. Yes, I have disabled it. And on router number 2 also interface fast Ethernet 1/0 and say no IP proxy ARP, right? Again PC1 cannot ping PC3. You can see for now ping will work because there is entry inside the ARP table of both router 1 and router 2, but after some time it will stop communication. PC1 cannot ping to PC3. After some time one entry will be flushed from the ARP table of router 1 and router 2. Try to understand the another method to configure a static route. First of all, how to verify the static route configuration? So command is do so run. We can check running configuration with the help of this command so run, but this command will show me the entire running configuration. Okay, but I want to see only a static route configuration, so we can filter the output with the help of this pipe section, and then we can say IP route. Show me the IP route configuration only. So it will show me only IP route configuration. I have run this command here. So whenever you are running command on router, try to filter the output as a student of CCNA. As a student of CCNA, you should run so run command that is correct. In the enable mode, you should run so run command to check the entire running configuration. But as a student of CCNP, you should filter the output. Okay, so I am going to remove this entry. Simply I am going to say no, and then I am going to paste this command. Done. I have removed the static route configuration from router number 1. If you will check routing table now, do so IP route, you can see inside the routing table there is no static route entry. Now I have removed the entry. On router number 2 also I am going to do same thing. Do so run section IP route. Say no, and let me remove this entry. Fine. Do so IP route. We don't have a static route. Again, we are going to configure indirectly connected network. First on router number 1. On router number 1, this time IP route 192.168.2.0, mask is 255.255.255.0, same. But earlier we configure exit interface here. This time I am going to configure next hop IP address. That I am telling to router, whenever you need to reach in this network, you will reach through this IP address, because this IP address is reachable from router number 1. Yes or no? Is 12.1.1.2 is reachable from router 1 or not?
Yes.
Yes, because this network is directly connected, right? So if I will configure a static route like this, then you can see the entry routing table. So IP route. Okay, now it's correct. This network is reachable via 12.1.1.2. This time router 1 will generate ARP for which IP address? For destination or for 12.1.1.2? For 12.1.1.2. So this time proxy ARP is not required. This time router know that this network is reachable from 12.1.1.2. But this time we have another problem. Another problem is, as you know, router need exit interface, but here there is no information about exit interface. So router have to check their routing table twice. First, it will came to know that whenever I need to forward the traffic in this network, I will forward traffic to 12.1.1.2. Again, router have to check this entry, that if I need to forward traffic to 12.1.1.2, I need to forward the traffic, exit the traffic from fast Ethernet 1/0. And guys, whenever router will check their routing table more than once, that is recursive lookup. Whenever router checks routing table to forward traffic, it is using their CPU utilization. So it is not good that router is checking their routing table twice to forward a traffic to a particular destination. This is called recursive lookup. Sometime interviewer can ask you directly this question also, that what is recursive lookup and in which scenario recursive lookup will occur and how to resolve it. Okay, so we will talk about the recursive lookup later. For now, this static entry is better because earlier router were installing this network like directly connected on fast Ethernet 0/0. Because of that, we need to enable proxy ARP on neighbor device. In the same way, on router number 2 also, I am going to configure a static route, IP route, and 192.168.1.0, 255.255.255.0. And what will be the next hop IP address for this network? This network is reachable through which IP address? 12.1.1.1. 1. Very good. And do so IP route. Inside the routing table, you can see the entry, right? And now if you will check, PC1 is able to ping. So you can see PC1 can ping PC3. Yes, proxy ARP is disabled. On router number 1, proxy ARP is disabled. So IP interface fast Ethernet 1/0, and we can say include IP proxy ARP. Proxy ARP is disable, right? Still ping is working, but again we have problem is recursive lookup. Router have to check the routing table twice. So guys, best way to configure a static route is, while configuring a static routing, you should provide both exit interface as well as next hop IP address. So on router number 1, we can configure both, like we can say, first of all, let me remove this static route configuration. Till here, any doubt to anybody?
No, sir.
Clear?
Yes, sir. We'll practice.
Yeah, you need to practice. Exactly. So best way to configure static routing is we should configure a network with both exit interface as well as next hop IP address. See, we understand the configuration with exit interface, there is problem of proxy ARP. We understand the configuration of static routing with next hop IP address, there is problem of recursive lookup. So best way is like this. First of all, let me remove the configuration, do so run and say section IP root. I'm going to remove this entry, say no to this, and then IP route and then network ID 192.168.2.0, submit mask 255.255.255.0, and then exit interface fast ethernet 1/0 and next hop IP address 12.1.1.2 like this. This is the best way to configure a static routing. Now if you will check routing table of this router, so IP route, you can see that this is the static route entry. Right now it have not installed this network like directly connected, so it's saying this network is reachable via 12.1.1.2, means it will generate ARP for 12.1.1.2, means gateway for this network is 12.1.1.2, and exit interface is also there, fast ethernet 1/0. Right, in the same way on router number 2 also we should configure the static route like this. Do so run section IP route, say no, and IP route 192.168.1.0 mask 255.255.255.0 and 12.1.1.1. so IP route. Now proxy ARP is enabled or disabled doesn't matter, you can see PC1 can ping to PC2 easily. Fine. So this is static routing configuration. Today we understand routing and static routing. Routing means forwarding packet from one network to another network, right? And static routing means to configure indirectly connected network. By default router know only directly connected networks. So we need to configure routes for all indirectly network manually. But static routing is suitable for a small network only, let's say because router 2 is connected with 100 networks. So we need to create how many entry on router number 1? 100. So again it is complicated. Let me put it in recording. Yes, now it is inside the recording. Okay, so that's all for today.